this video, we're going to talk about properties of transcendental functions. This is review from algebra. Transcendental functions are our exponential functions and also our logarithmic functions. And after teaching for many years, I've found it's really helpful to make sure students know all of these properties and understand how to deal with transcendental functions before we start using calculus to apply derivatives to them. And we have properties for derivatives of e to the x as well as logarithms. So let's just start by considering the fact that we could have an exponential function or also a logarithmic. Okay, so we've got exponential and logarithmic. An exponential function might look like y equals some number a to the x. One thing that we state, a is the base. A cannot equal 1 and a must be positive. So we say greater than 0 to mean positive. Same thing for a logarithmic. We could have y equals log base a of x. One thing that we want to make sure that we remember is that these two functions are inverses of each other, right? So we can take a logarithm and convert it into an exponential. Similarly, exponential expression could be converted into something that is logarithmic. Now, as I said, this exponential function could have any base. It could be y equals 2 to the x or y equals 10 to the x. And oftentimes, and what we'll see a lot in calculus, is we'll have y equals e to the x, e being Euler's number, irrational number, approximately 2.718. So we could also write logarithms using the same notation. Y equals log base 2 of x. If we want to talk about log base 10 of x, well, that's a common log, and so generally that base is not written. All right, so these would be inverse expressions. Here we have our common log, and a common log is base 10. And then if we were dealing with natural log, y equals log base e of x, log base e is a natural log, so we write that as ln of x. Okay, and again, these guys are exponential. In all these situations, a represents the base, both logarithmic and exponential. A cannot be a negative number, so a must be greater than 0, and a is not allowed to equal 1. So these are different types of logarithmic or exponential expressions you may see. One very helpful property we use is our conversion formula. So something that is important is to be able to convert between logarithmic and exponential form. So we may have some base a to maybe the y equals x. And what we know is that can be converted into logarithmic form, log base a of x equals y. So what you want to notice is that base a remained the same, and then the x and the y switch sides. And that, x and y switching places is something that is indicative of an inverse. And as I said, logarithmic and exponential functions are inverses. So I just wanted to make sure you guys, my students, were familiar with the properties and the logarithm and exponential notation. And then I want to review a couple of our power, product, quotient rule properties for logarithmic and exponential equations, because sometimes it helps us if we can use those first before we apply the calculus. Again, using the algebra first to simplify it makes the calculus really easy. So if I make a list of properties, we have a product rule for exponential functions. So a to the m times a to the n. If I'm multiplying same bases, I would add those exponents. My quotient rule If I'm dividing same bases, I'm going to subtract those exponents. And my power rule. If I have a power raised to another power, that would be the same as multiplying the exponents. So we have three, a product, quotient, and power rule for logarithms. One thing we know is that the log of m times n, regardless of the base, log base a of m times n, that would be the same as log base a of m plus log base a of n. So we could add those. We separate the factors and add the two logs. The same idea occurs with the quotient rule. We'll say log base a again. So log base a of a quotient m over n equals log base a of m minus log base a of n. And then we also have a power rule. So if I have log base a of m raised to some nth power, that involves multiplication. That n can come in the front, and that would be n times log base a of the argument m. All right, so draw a little line there to separate, but we have three rules for exponential functions, three rules for logarithmic functions. We also have a few other properties. So considering exponentials, any base raised to the 0 will always be 1. Any base raised to the first is equal to itself. And that's similar with logarithms. The log base a of 1 would equal 0, and the log base a of itself, when the argument and the base match, that's equal to 1. All right. Two more exponential rules that we've already been using a lot, but I'll just include them. If we have a negative power, that is the same as this reciprocal property. So putting it to the other side of the fraction, making it positive. And then also if we have a rational power, that is the same 1 over n. That would be the same as the nth root of a. All right? So properties of logs, properties of exponentials. One last thing I'm going to add in this review video. We have log base b of the argument. So formally, I always wrote base A. I'm just writing base B here to remind us that that is my base. The expression that we are taking the log of, that's called the argument. So I like to point that out. This, whatever we have in the parentheses behind the log, is the argument, because I use that term a lot. And, you know, a lot of the times I get from a student, well, Ms. Stein, what even is a log? So we have the fact that a log is the power to which you raise the base to get the argument. So in this situation, like if we had log base 2 of 8, 2 to what power equals 8? 3. And thinking about converting that, that's the same as 2 cubed equals 8. So again, just make sure you're comfortable using your properties of logarithms and exponentials and knowing how to convert. In the next video, we will talk about how to take derivatives of logarithmic and exponential functions, and then we'll have one last set where we use the chain rule with some of these logarithmic and exponential functions, and the product rule and the quotient rule, so bringing them all together.